In this question, we're told that a buoy is floating on the surface of the sea and its height above the surface is modelled by this equation, and I'm asked to sketch a graph of this in part A. So I've first just drawn the regular sine graph down here because I can see that this is a transformation of it. This 180 on the inside here, I know that that's going to divide all of the, in this case, t coordinates by 180. It's going to squash this graph by a scale factor of 1 over 180 in the x direction. So I'm dividing all of the x coordinates by 180. So this point here, where it usually goes through the x-axis, or the t-axis in this case, is at 180. When I divide that by 180, it's now going to be at 1 here. And the point here that was at 360, when I divide that by 180, I'm going to get 2. When I divide the 540 by 180, I'm going to get 3. So what's happening here is when I divide this graph by 180, the graph will now look something like this. And so on. Then I need to deal with the 1/2 at the front there. I know that's going to be dividing my y coordinates by 2. So instead of going up to 1 like the sine graph usually does, it's now just going to be going up to 1/2 and down to -1/2. So let me now draw my final version of this graph. Let me just delete or rub out this old bit. So it's going to be going up to 1/2 at 1/2, down to 0 at 1, down to -1/2 at 1.5, up to 0 at 2, up to 1/2 at 2.5, down to 0 at 3, and so on. And there we go. This is the graph of 1/2 sine 180t. And you can type that into Desmos online and you can check that graph for yourself. Part B of the question says write down. So first of all, I'm just going to write down my answer here. I don't need to calculate anything. Notice it's only 1 mark as well. Write down the number of times the buoy is 0.4 meters above its still water position during the first 10 seconds. So, how many times is it 40 centimeters above its original position during the first 10 seconds? Let's have a look at our graph to help with this. So where is 40 centimeters or 0.4 meters on my graph? It's here. Obviously the half is 0.5, so 0.4 is just below that. And it might help if I drew a line across here at 0.4. And then let's count the number of times that the height of the buoy is 0.4 meters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times is my answer to part B. And finally, part C, state one reason why this model might not be realistic. Well, this is a very uniform graph here, saying that the height of the buoy is always going to be going up to 1/2 meter, going down to -1/2 meter, and the period of each oscillation is 2 seconds. So it takes 1 second to go up to its maximum, then back down to its equilibrium position here, and then down, and so on. So it takes 2 seconds for one full cycle, and that, according to the model, that seems to be the same. That seems to be constant, and I think that's unrealistic because the waves in the ocean are not going to be constant. They're not going to be uniform. So waves in ocean are not uniform. In reality, we're going to get some that are really big, we're going to get some that are really small. They're not all going to be the same. And so if the waves are not uniform, the maximum displacement, the maximum height, and the minimum height that it reaches will change. Not always be 0.5. So waves in the ocean are not uniform, so the maximum displacement should change. Or I could say that the period should change as well. Sometimes it'll take 2 seconds to do a full cycle, but sometimes when it's a particularly big wave, it might take 3 seconds to do a cycle, or 4 seconds to do a cycle. So basically I'm saying that in reality, the maximum displacement or the period should change, because we know that the waves in an ocean are not all going to be the same. So either one of these, you could say, would be your answer for part C.